In lesson 5.8, we are going to do some word problems. The first example is the Toronto Stock Exchange is housed in the Exchange Tower. From the top of the building, the angle of depression of a point on the ground is 56 degrees. From a point 20 meters further out, the angle of elevation to the top of the building is 48 degrees. Find the height of the building. So very important here is to start off with drawing a diagram and putting in the information in the word problem. So this is the ground level, and let's say this is the tower. And we have been given the angle of depression. So I'm going to draw a horizontal line, and the angle of depression from there is given to us as 56 degrees. And so that makes this also 56 degrees. And then the angle of elevation from another point further out. So further out, let's say it's over here. And the elevation from that point to the top of the building is 48 degrees. This angle here is 48 degrees. Okay, so this is a straight line, though it doesn't look like it, but it is all in one line. So you have now here a right angle triangle. You are asked to find the height of the tower. So this is the tower. And we're going to label there's two right triangles we can see here. One is triangle A, let's call this point DC. And the other one is the second right angle triangle, which is BDC. They're both right angle triangles. And this point, the distance between B and A is 20 meters. And we're asked to find the height of the building. So we'll find H. Distance between A and C is not known. Let's call it X. So let's look at triangle ADC, which is this right triangle. And in this triangle, tan of 56 degrees is equal to opposite over adjacent, so H over X. So the height of the building will be X times tan 56 degrees. So if you find the value of X, we can easily solve for height of the building. In triangle DBC, which is the second right triangle, so it's this larger one here, we notice that tan of 48 degrees equals H over, so the opposite side over adjacent side. The adjacent side is now 20 plus X, okay, because that's the entire length from B to C. And therefore, solving for H, we get H equals 20 plus X times tan 48 degrees. So we have now two expressions for height of the building, and they both have to be the same. So we're going to equate 1 and 2. So that means X times tan 56 degrees is equal to H plus X times tan 48 degrees. Okay, so let's solve this equation in X. So you have X times tan of 56 minus X times sorry, I made a mistake here. There's not each, this is B20 over here. Just going to correct that. This is equal to 20 plus x times tan 48. So then in this step we have 20 times tan 48, 20 plus x times tan 48. So x times tan 56 minus x times tan of 48 equals 20 times tan 48. So x, factoring x out over here, tan of 56 minus tan of 48 degrees equals 20 times tan 48. So we can isolate the x here. X equals 20 times tan of 48 divided by tan of 56 degrees minus tan of 48 degrees. So you put that in your calculator and get the answer to one decimal place. It works out to 59.7 meters. So once we have x, we can find the height of the building. The height of the building, h, is equal to 59.7 times tan of 56 degrees, which is equal to 88.5. Therefore, the height of the building is 88.5 meters. That's the answer.